Today I'd like to look at the integration technique of integration by parts. This technique is an attempt to work the product rule from differentiation backwards. So let's look at where this comes from. So let's remind ourselves the product rule of differentiation. So if you want to take the derivative with respect to x of the product of two functions. I'm going to call them u and v. So those are both functions of x, and we're differentiating with respect to x. So product rule is called for here. So remember, you take the derivative of the first function with respect to x times the second plus the first times the derivative of the second with respect to x. All right. Now, the idea here is let's flip this around and go ahead and integrate both sides of that. So in other words, on both sides of this equation, I'm going to take an integral with respect to x, integral with respect to x. Now, what did we do here? We started with u times v. This is the derivative of it, then integrated. So that's going to just take us back to u times v. Now technically that's also plus a constant, but there's still going to be integrals on this side of the equation remaining, so I'm not going to write the plus c because as long as there's an integral still happening, we can assume that that plus c is going to happen once that final integral is done. So on this side, I'm going to break this up into two integrals. So I've got the integral here of, and I'm going to write this the other way around for reasons you'll see in just a second, du dx and dx plus the integral u of x dv dx dx. Now, remember from Calc 1, that thing right there, du dx, so the derivative of u with respect to x times dx was what we defined as the differential du. And this thing, dv dx dx, was the differential dv. So I'm going to write it in that differential notation. So we have the integral of v of x du plus the integral of u of x dv. Now, we have two integrals here, and the idea is with integration by parts that one of those integrals will be our starting integral, and we're replacing it with the other integral. So algebraically, I'd like to solve this for one or the other integral, and there's really no reason to pick one over the other, just sort of tradition. We'll isolate this u dv. So I have that the integral of u of x dv, and subtract that to the other side, is u of x v of x minus the integral v of x du. And this is our integration by parts formula here. Let's see what it does. It says if you have an integral, think about what these two pieces are. U of x is some function of x, but v of x is some function of x, and this is its differential. So really this is a product of two functions. So it's saying if you have an integral with a product of two functions, it's equal to that first function times v, which this would be its differential, minus this new integral that involves v and du. Remember, v is a function of x, but what is du? Du is u's differential, so that's a product as well. So you're starting with an integral of a product, and you're ending with an integral of a product. So this is not a technique that just gives us the answer to the integral. All it does is take some integral we started with and replace it with a new one. So under the right circumstances, the hope is that this initial integral was something we didn't know the antiderivative of, whereas this new one is one we do. So this won't work in all cases, but in certain situations, you are going to end up with something you can integrate there. Now, as a shorthand, you'll often see this just written u dv equals the integral u times v minus the integral of v du, just dropping the function notation there. But it's important to remember where these are coming from. We started with this idea of a product of two functions. These du's and dv's are differentials. Another thing to note is this is an integral with respect to x underneath it all, and so is this. And these are functions of x. The u's and v's are just names we're giving things, so we're never actually changing the variable. We're going to start with an integral of x and end with an integral of x. At no point do we switch to a new variable. Unlike u substitution, these will be x's from start to finish. So next time we'll look at a concrete example of using this integration by parts formula.